And today we like to kick off the sessions in this room with a topic that couldn't be of more importance, I would say. If you think back, I think it was Amazon that announced that Alexa can imitate, or let's say can read the bedtime story to children using the voice of the grandmom. This is something the world certainly does not really need, but instead, there's a lot of errors and a lot of things that can go wrong. And an expert who can tell us more about what can go wrong is Will. Will is currently working at NVIDIA. He's one of the experts in breaking machine learning models. Previously was at Microsoft, and I'm very happy to leave the stage to you, Will. Please join me in applauding and giving a warm welcome to Will.
Thank you. Thank you. So this is machine learning and the optimization of virtual personae for phishing, mostly. So as Christian and I were talking about what I wanted to talk about, or what he wanted me to talk about, this is the title that he came up with. And then so I put comma mostly because there's other things that I kind of wanted to get at. And so we will talk about Persona for phishing and all of the tools that you can use. And then I have a talk from B-Sides Salt Lake 2019 that is on that topic as well, and we'll cover some of that. But what's funny is if you look in your schedule or you look online, there's a picture of this person, which isn't me. So I thought that was a perfect identity piece. So anyone who didn't attend is not going to know that that's not me. But currently I'm a machine learning security researcher at NVIDIA, and I get to hang out and attack machine learning models, both from the system perspective, like the classic red teaming. So I just had a talk in LabsCon where I released a couple of code execution techniques for machine learning libraries. Then I also get to attack the models, so algorithmically attack models, so evasion, inversion, inference poisoning, that sort of thing. Previously, I was the red team lead for the Azure Trustworthy Machine Learning team. It was like a new team at Microsoft where we were kind of responsible for the same thing, building methodologies, things like that. And I was a senior security consultant at Silent Brick Security, where I just did your classic red teaming and taught. We have a class, so if you're into red teaming, there's a class that you can take called Dark Side Ops 1 and 2, and they teach you how to write malware. So you leave with your own custom toolkit. So if that's something interesting to you, I highly recommend that course. But I am a little biased. But my motivations for getting into machine learning security are pretty much that. Machine learning security requires security because we deploy it into production environments. So if that weren't the case, then we wouldn't need to worry about it. But as it is the case, information security comes into purview. So as that means, sort of collecting data, deploying systems into, edge devices, whatever it might be, they already require some sort of security. And so when you introduce machine learning or any new technology into that environment, by default, it has to be secure, right? It can't weaken the security of a system just because it's new and fancy. And honestly, I find machine learning just fun. So I would say if you're interested in it, but you don't like numbers or math, then you might not like it as much. But if you're someone who thoroughly enjoys watching numbers scroll across a dark screen while you wait for something to finish, this is probably for you. And we're really just getting started with the risks and describing them, showing them, educating people about them, figuring out what the impact actually is of any given attack. And the spoiler is it's contextual, so it really depends on the thing. But there isn't a good framework for reasoning about risk in these systems. So before we kind of dive in, we're going to spend just a very brief set of slides on sort of the machine learning lifecycle. And this very complicated graph here, you can go to this paper, and this is probably the most complete sort of chart that I've seen. But effectively, it comes in 6 steps. So you have data collection, processing, you have your model training, and then your evaluation, making sure that it's good to be deployed. Then you have deployment, where it's deployed on your edge or wherever you want to deploy it. And then you have system monitoring, where you're making sure that it's acting appropriately in the right environment. And so I just have some very simple pictures. Again, we're going to go through this quite quickly. So out in the world, we have data. And this is, we have our bunnies or rabbits here. And there's a process by which web scraping, what have you, you go and collect data and you store it on a server or on your local host. And it's just the data that you collected for the task. So you have some idea of like what you want to do, like facial recognition. So unless you want to, recognize faces of rabbits, or humans, you need to go and get whatever is representative of your task that'll help you solve it. Then you kind of have data processing, and that's where you take whatever you put on your server and you turn it into numbers. So, algorithms are math; they can't work on words or just straight images. So you have to represent your data somehow in numbers, and there's a number of different strategies for that. And then we have our labels. So we're labeling blue bunny, or the colors blue bunny, green bunny, baby blue bunny, whatever it is. And so this is kind of the representation that you give to an algorithm for training. And there are some, I don't know if you can see these. There's a little file down here, so there's some, so it kind of builds. So then we get into model training. And this is a relatively simple, I shouldn't say it's not a relatively simple process, but effectively, you introduce your data to your model, and then there's a function that you're asking it to classify this rabbit in the right category. And there's this forward pass where it calculates forward, and then the magic of deep learning is the back propagation of errors. So the difference between what you gave it and then what the model predicted. And then through that back propagation, it adjusts the parameters of the model, which are, again, just numbers, such that it's able to fit data. It's able to represent data in an accurate way. And then after this, you have sort of your model evaluation. So outside of the data we collected earlier, we took some portion of that data and we never gave it to the model, so it has no idea what it looks like. And then after we think the model is trained, we can give it, all this data that it's never seen before, and hopefully it's accurate. And then we deploy our model into some, could be a web endpoint, could be an API on your Windows host, could be in a car, could be anywhere you want to deploy it, on a phone. And you'll take these files that we had earlier, so the processing code will just go into your deployment package. Then you have your model, which contains the math, and then the weights, which is the really valuable part. And then you write a wrapper that says when you submit an image, we're going to put it through a pipeline, and you'll get your prediction back. And I'd say this is from a black box perspective, when you're attacking models, like this is ultimately what you're looking for, right? Like you're looking for that endpoint where you can submit inputs and get outputs. And then when you deploy it, you obviously monitor it. So here I've changed the colors of the rabbits to represent some sort of data shift. So we trained our model at point A, and at some point during, across several weeks, let's say, the distribution of the data has shifted, and so our model is no longer quite as accurate as it was, and so now you just repeat that process over and over, and as your data moves through time or whatever you have. Okay, so now we're going to get into sort of a real-world example. So this is obviously a facial recognition. And in terms of like authentication or your identity of who you are, your face is that's how it recognizes you. But there's that same process up front. So algorithms can't work on this face. They need some way to represent it in numbers. And so there's facial point maps. There's the red box that is called a bounding box. It detects the face. And then again in the bottom we have all of the numbers that you're all familiar with. That we just discussed. And so always there's this representation of some raw data into numbers, and that becomes you to the model, right? That becomes you. So you are sure you're a face, but you can also be described numerically. And I think that's a really powerful concept in terms of what you can do with that right now. So when we've described things numerically, we can measure distances between, pairwise. Let's say we wanted to go across the room and say, what's the difference between these two people? When we can describe it, obviously we can be like, I have blonde hair, you have dark hair, blah, blah, blah. But, maybe that becomes a categorical variable. And in a system context, this might look like, we Windows Hello for Business. So when you log into your Windows laptop, now, you get the infrared cameras, and then it's like, awesome, you are who, I think you are. And really the only difference here from our training setting is that now we have some business logic. So we have to create some threshold that says, this is malware, this is not malware. This is Will Pearce, this is not Will Pearce, right? And so tuning that threshold is an art in and of itself. And it kind of introduces like this probability into what used to be a very like linear system. Either, if you're familiar with pass the hash attacks, where you have knowledge of a password and the hash is effectively that password. Now you've introduced some probabilities into it. But again, I think the business logic here is obviously the different one. But effectively, like your identity, like the person that you are, and that representation lives on disk, right? So it's a file that lives in C Windows System 32, your Win bio database. So it's a DAT file that has a binary representation. So when you put your face in front of Windows Hello for Business, it'll open that file and then compare, do all the processing for your current face. So get an ascent, and then it'll compare those two values, right? And so there you could do like an if distance. So it'll measure the distance between those two vectors and say, I think this is within some error that I think it's the person that I think it is. But effectively, with images or video or any information, you can create any representation you want. And then on the flip side, like any data that you can represent numerically, like you can create a synthetic version of, right? So you can create synthetic versions of, you can train models that'll create synthetic versions of faces, which we'll see later on. This is, okay, so this is another way to represent data, I suppose, or an identity. This is a k-nearest neighbors projection of an Active Directory environment where I took the usernames and their group memberships, and those became like the labels and then the document. So there's an algorithm called word2vec or doc2vec where you can take a document and then it'll run an algorithm, and then you'll get that document in a numerical form. And then you just project, these items into a two-dimensional space, even though they're multidimensional. And you can see already, the algorithm's able to separate users from one to the next. And so in the middle, you have a lot of domain admins for some reason. I don't know why domain admins congregate toward the middle. But, if you know anything about Active Directory or networks, you could maybe think, okay, well, I wonder if orange is just the domain users group. Who's in this group? But if you wanted to, this becomes your identity. Your group membership is your identity within this space. And if you wanted to say, let's say we compromised three. A use case for this, we have 3 user passwords, right? And we have this projection. We can now measure the distance between all of the users that we have, and then any user that we want to get to. So theoretically, you would say, I'm going to start with the user that is closest to a domain admin, right? And normally we would say we'd maybe open up Bloodhound and we'd follow like the little graph. And maybe you'd have a path or not, but that's irrespective of distance. And those, I suppose, are control paths, but it does use Dijkstra's shortest path algorithm to find those shortest paths. And if you're not familiar with Bloodhound, or if you're familiar with math and Bloodhound, you can actually go in and change that shortest path algorithm, or you can weight it in particular ways that make it really nice. But ultimately, like, I think I want to make the point that it doesn't matter whether it's voice, your heart rate, your breathing rate, your face. Like, you can always represent data abstractly with these numbers, and that. I think what I want you to come away with is it's like a composite, like your identity is a composite of things. It's not like any one thing. So when I think about a user in a network, or what you're ultimately trying to get at with an algorithmic attack is like you're trying to get the right representation for that target that you want. So you're not any one thing. And this is my, I don't know, if the live, laugh, love thing. Is that a familiar concept here? No. There are like grandmas that have like sayings in America, and like live, laugh, love is like one of those grandma sayings. And so algorithms are empty and models are not, or that's my like grandma live, laugh, love saying. In that algorithms don't care. Like algorithms will just work on data, right? And they'll pass it through and they'll give you numbers and it doesn't matter. But models are not. Models are trained, so they compress data. So as you're thinking about risks, just keep this one in the back of your mind. Okay, so now we're going to talk about social media, which is actually maybe what we're talking about. This is GPT-3. So when we talk about phishing and trust and identity, and the first picture, right? That could be a picture on LinkedIn. I could be reaching out to you for a job. Looks very promising. It pays really well because why not? Doesn't exist. But I asked GPT-3 to write a long description for a sales executive that makes $400K a year. And this is kind of what it created for me. So if you're used to phishing, you have your 25 templates, you have your 15 personas, and you're like, okay, let me send 5 in with 3 different payloads or whatever, and let's see what comes back. And then you painstakingly go through LinkedIn and copy and paste code and don't make it, copy and paste job descriptions and try to make it look official. But now this GPT-3 thing allows you to just generate code, generate text content like infinitely, and it's all unique. So, I don't know if you've ever been caught phishing, and then you've had the same subject line, and then there's you were lazy and the SOC just typed in the subject line and then found all of your targets. This is no longer the case. So now you can instantly generate as many unique emails as you want. And then you kind of combine that with something like StyleGAN3 with, this person does not exist. So this lady doesn't exist, and this is probably could be old news. I'm not sure. But for a long time, we would, the way we created personas was we would go to Google, we would look for some image, and then we'd go to like the 100th page. just in case anyone did any sort of IR on our LinkedIn, it wouldn't be like they'd bring it up in Google or reverse image search. It wouldn't be like that close. But now you can just generate people ad nauseum. And so now you put this on LinkedIn, and now you have a persona that is just completely synthetically generated, and there's no trace. And you can just do this for the rest of time. And then I kind of wanted to see what how generic or general it could be. And so I just asked it to write a job description for a cat that has an important banking executive job, making 6,000 tuna a year. And it came out with something, so if I wanted to go and fish cats, I could. And my favorite part of it is at the end where it says, and a lot of tuna. So it makes it sort of, I like to imagine that GPT-3 is making it more appetizing for cats specifically. But you can, invent yourself, right? Like you can invent yourself. And this is a slide from my talk beside Salt Lake. But you LinkedIn, there's someone, they do something, and as an operator or network operator, you can sort of manage hundreds of personas this way rather than having to create them by hand, which is laborious. And so that being said, it does make it more painful when you burn them. And so maybe it makes you lazy, I'm not sure. And now we're into sort of the deepfake territory. So these visual deepfakes, the Zelensky deepfake. And what's kind of wild about this Zelensky deepfake is actually, has anyone seen the Tom Cruise deepfakes? And they're just like perfect. They're so good, you would never know. And then you watch the Zelensky deepfake and it's terrible. And it was kind of needlessly terrible, right? Like the technology exists to have a very good deepfake of this thing. And so whoever built this deepfake is probably not that skilled at what they do. But I think the lesson here is that it's not saying, oh, this is a bad one, look how terrible it is. It's like, okay, well, let's look at Tom Cruise and then let's apply that same skill set to this Zelensky deepfake. And I think it is a very different situation. And, you know, defenses or not, mitigations, it's hard. It's just because it's so infinite. But so if you want to work on this, actually, one thing I forgot to put in the beginning is I hang out at the AI Village for DEF CON, and this year we ran a CTF. Did anyone participate in the CTF? In the channel? It was online. It was on Kaggle. But in it, we had like a deepfake detector. So obviously, once you can create deepfakes, people want to detect deepfakes. So the idea there was just because you have a detection for something doesn't mean it's solved, right? Like now we're just in this phase where we're just back at information security, cat and mouse, these things. And there are lots of stories of people using deepfakes for various things. Okay, and actually I have a demo now. Okay. Let's see if this works.
Hey everyone, NVIDIA is happy to be at Swiss Cyberstorm.
So this is a voice model of our CEO that we have control of. But if you've seen our GTC conference is, they used synthetic media. So in their latest one, actually, they had AI write a piece of music, and then it played the outro. And you would never know that it was AI generated. I mean, it was performed by humans, but the music piece itself was generated. But so this is.
Hey everyone, NVIDIA is happy to be at Swiss Cyberstorm.
And so you would never know the difference. So if someone, I mean, obviously, I don't think it's a perfect scenario because the CEO is kind of, I think, an overdone trope in terms of phishing. Like you're probably much more successful if you were to copy like a manager of somebody and leave them a voicemail. Like how often does a CEO of a Fortune 500 company call you and ask you to send them gift cards or whatever? But I think the point is, actually, let's go.
Thank you for taking the time to learn about ML security.
So there are some things that's not perfect, right? But like over the phone, there's maybe some wind, there's some noise. I think it's a much more compelling, it's a much more compelling deepfake than visuals or videos. I think videos, it's all of our senses. So it's eyes, ears, right? Like there's some context to it. But, we kind of expect like rough phone calls or it to be like a noisier signal. So I think it's a little nicer.
Will is my favorite employee.
And it's not perfect, but it's good enough. Okay, so protections, new protocols, responsibilities for media companies. These all have questions. I put blockchain in gray because I don't know if that's a dirty word here. But bioauth in general, there's a lot of detections, liveness detection, texture analysis of your face. So I think the face space or the visual space is a much harder space to create deepfakes in. The audio space is relatively easier. For Windows, you have your event monitoring. Windows Hello for Business recently has had integrations with Active Directory now. So you can auth with your face to Active Directory, where before it was just local. And I think in conclusion, I think I want, even though we talked about deepfakes, think of your identity as a composite, like as a distribution and not as any one thing. So as you think about all the different paths, but think about it in any sort of data. So I think get to an abstract representation of your problem, and then think that work through it that way, rather than saying I want to work with pictures, or an identity is a composite of your actions, your person, your face, what the car you drive, how you got here, the people you hang out with, right? Like those are all features. And then with that, I want to say thank you. Email. You can email me, follow me on Twitter, or I have a bunch of code on GitHub that might be interesting for you.